Okay, I'm back again. Now, we've already talked about the Maxwell Boltzmann distribution curve and we've connected it to the use of catalyst. I missed one thing off that video, I'm afraid. My apologies. I've seen quite a few exam questions asking for you to highlight on the curve where the mean energy of the particles would be. Now, that means we need to find the point where the two half areas underneath the curve are equal. And that is not going to be at the peak. It is going to be slightly to the right. So you could draw a line down and say this here is the mean energy of the particles. So now what I want to look at is the effect of raising the temperature. If we raise the temperature, we increase the number of particles which have higher energy. So this means that this curve is going to shift and our peak is going to move to the right. So let's have a look. Here's one I made earlier. So it still starts at 0. That's a very messy line on my behalf. We can see our peak is to the right of the original peak. So the green line is the higher temperature. And we can see that the tail is fatter there. Okay. This isn't changing the activation energy. Only the catalyst is going to change the activation energy. So if you got asked to draw a second distribution curve showing the distribution at a higher temperature, make sure it starts at 0, make sure your peak is lower and it is to the right of the original peak. And you need to try and get the area underneath each curve to be approximately equal, because that, remember, is the number of particles and that is not going to change. So if you get asked to explain why raising the temperature increases the rate of reaction, making reference to the Maxwell-Boltzmann distribution curve, let's have a look at what a great answer would be. So you need to state that raising the temperature shifts the curve to the right, and this increases the number of molecules with an energy in excess of the activation energy. Because if we look back at this, the area under the green line at a higher temperature is much bigger than the original distribution curve at a lower temperature. So we can then state that it increases the number of molecules with an energy in excess of the activation energy, and therefore there will be more successful collisions occurring per unit of time. Remember, you've always got to give the idea of frequency of collisions, of successful collisions, and then to tidy it off so the rate increases.